For this project, we were supposed to create a robot that has the ability to follow a track, and while it's following a track, it has the ability to detect a can. Once it detects the can, it will pick up the can and place that can into a certain bin, to either the black bin or the white bin, depending on what color the can is. For my robot, this is my initial sketch. I was thinking of making it similar to the first project of the square bot, and then have a bin on the ends of the bot and have a conveyor belt that is attached to the back of the robot, that will, once the robot grabs the can, it'll place it on the conveyor belt, and the conveyor belt will register whether if it's black or white, and it'll shift it over either to the black bin or the white bin. What I'm building right now is the arm of the robot. What its function is to lift the can up and down, so then it's able to lift the can off the ground. Also, it'll be holding the hand of the robot as well. From this picture, you can see from the gear ratio, it goes from small to large, which that means that there's low speed but high torque. With a higher torque, there's more strength for the arm to lift the hand and the can. Also, I changed the design. The plates were a little too long, so I shortened them, and then I connected the arm to the plates, and also I added a potentiometer to the side of the plate in order to determine when to turn on the motor and when to turn it off. Here I have the end design of the hand of the robot. As you can see, there are two metal plates connected to two gears. Those are considered the fingers of the hand. Also, I have an ultrasonic sensor and a potentiometer attached at the bottom of the base. Also, there's a small gear attached to the motor of the hand, and that small gear is attached to one of the large gears. And when the small gear starts, it has the ability to extend both fingers out at the same time, or join both fingers in at the same time, and that is determined by the potentiometer. So depending on the value of the potentiometer, it will either extend the fingers out or join the fingers in. The purpose of the ultrasonic sensor is used to detect the distance between the robot to the can. So usually the hand is in the retracted out position. So once the can reaches a certain distance, say around 10 centimeters, the robot will stop and it will join the fingers in and grab the can. Here I have the almost finished product of the robot. As you can see, I did not follow up on my sketches. Instead of using the design I once had that is similar to the square bot from the first project, I actually used a metal or aluminum plate as the base, and also under that plate there is a multi-directional wheel connected at the end of the base and to the front of the base where the arm is. I have two motors connected to each side of the wheel. There's a small metal gear connected to a large plastic gear, which will in turn give it a really low speed but a high torque, so it has enough strength to push all that weight that is on the base of the robot.
You have to keep eliminating.
There were a lot of complications when building this robot. As you can see from the previous video seen with the hand, it was able to open and close once, but after that it needed a little help to open and close, and it would only open and close at certain increments. Also, another problem arose was lifting the arm as well. We couldn't really figure out the problem. We thought it was the code of the program while we were using a while loop to have the arm raise up when the potentiometer reads at a certain value. Also, that complication happened with the hand when we use a while loop to determine when to close the fingers depending on the value of the potentiometer. We did a couple of troubleshooting when we tested to see what the value was for the potentiometer for both the hand and the arm, and the value displayed it at 57. But when we created a separate program, the values for it ranged from 222 for the arm when it goes all the way up, and then 702 when the arm goes all the way down. And then for the hand, when the hand is fully extended, it's 1020, and then when the fingers are joined together, it is at 950. But for the coded program, it came at 57, and we have no clue why it was showing a value of 57 when the code asked for the hand to join together when it is above over 600. Also, we tried to do the best we can to figure it out, and we think it was either the motors that are connected, the controllers, or even the Arduino that was causing the problems, but we couldn't really find the problem overall.